Hello, we are Zach and Brianne, and we are going to discuss categorizing journal articles. I will start us off with an introduction to the data and the project, and will then turn the time over to Zach to discuss topic modeling and classification modeling. Then I'll close out the presentation with some recommendations. We are focusing our attention on academia individuals, whether they be students or professors, doing research or writing journal articles. We want to help them succeed. Our objective is in two parts. The first is topic modeling, where we categorize articles into similar topics. The second is a classification process, which will allow us to classify new articles based on the words in the abstracts and titles. This will then allow us to see what other articles are in the same classified topic, which we can then use to find best matches for journals for publication. Our data was pulled from the open source archive at Cornell University called Archive. This archive contains 2.2 million articles with information on title, abstract, terms or topics, and other article-specific details. We used a list of 21 keywords to pull data to limit the size and received 64.5 thousand articles, which was then reduced to 50,000 articles after we removed duplicate titles because those were likely on the same topic and would bog down our processing. Additionally, we only pulled information on the title, abstract, and terms. Terms ended up being less helpful because the articles were placed in up to 11 different terms or topics, which made developing models more difficult. I'll turn the time over to Zach to cover the modeling part of the project, then I'll return to discuss what this means for you.
Thanks, Brianne. The first step in our project was to develop categories using a technique called topic modeling. Topic modeling is a technique in natural language processing that involves identifying and extracting the underlying themes or topics in a collection of text documents. The goal of topic modeling is to identify a set of topics that can capture the main themes and ideas present in the corpus and determine the distribution of these topics within each document. We tried three popular approaches to topic modeling: non-negative matrix factorization, or NMF for short, latent semantic analysis, or LSA for short, and latent Dirichlet allocation, or LDA for short. After reviewing the results of each of these models previously mentioned, we found that NMF did the best at generating topics that were clear and represented the corpus the best. As you can see in the word clouds at the bottom of the slide, that the categories generated from our NMF model are pretty good, but they are not perfect. There are still opportunities for improvement, doing things like customize stop word list and add n-grams, and potentially using lemmas to address word stemmings that we see in the cloud pictures below, like graphs and graphs. Now that we have generated our topic categories using NMF, we then moved on to build our classification models. Classification modeling is a supervised learning technique in machine learning that involves predicting a category label or class for a given input data point. The goal of classification modeling is to learn a mapping function between the input features and the target labels, which can then be used to predict the class of new unseen data points. Classification models can be trained using a variety of algorithms such as decision trees, logistic regression, support vector machines, and neural networks. For this project, we tried only two classification models, multinomial naive Bayes and multinomial logistic regression. Let's review each of them in more depth. Multinomial naive Bayes is a probabilistic classification algorithm based on Bayes' theorem, which assumes the probability of a particular class is dependent on the probabilities of each attribute given that class. It is commonly used in natural language processing and text classification tasks, where the goal is to classify a text document into one of several predefined categories. The results of our multinomial naive Bayes model were terrible. The overall AUC ROC score was 0.834 and several of our categories had an AUC score that were no better than guessing or flipping a coin. The AUC score tells us how efficient the model is. The higher the AUC, the better the model's performance at distinguishing between the positive and negative classes. An AUC score of 1 means the classifier can perfectly distinguish between all the positive and negative class points. An AUC score of 0.5 is no better than guessing or flipping a coin. The next model we tried was multinomial logistic regression. Multinomial logistic regression is a popular method for text classification that extends binary logistic regression to handle multi-class problems. In text classification, the goal is to classify a document into one of several predefined categories based on its text content. The results of our model were great. The overall AUC score was 0.963, which outperformed our multinomial naive Bayes model overall and on each of the categories. Given our results, we suggest that we utilize the multinomial logistic regression moving forward.
Thanks, Zach. So going forward, if you would like to implement these models as they stand, we recommend using the logistic regression model that we established that utilizes the non-negative matrix factorization topic model to make the topics. If you would like improvement, there are many options, most of which would bore you as they pertain to the nitty-gritty of data input, cleaning, and model formations. We would, however, recommend using the fine-tuning and cleanup improvements before utilizing a more complex and more costly model. As a note, as you may recall, we pulled 64,000 article entries from an archive of 2.2 million articles. Once the methods are improved and customized accordingly, we can increase the number of articles pulled to have a broader knowledge for categorizing journal articles in the future. Thank you for your time in listening to us. We hope to continue working with you in the future.